So India has a very visionary goal of becoming a Viksit Bharat.
लक्ष्य है विकसित भारत बनाना.
What do you think about India in general? Are we on the right track?
So India has tremendous potential, as you know. We have so many young, energetic people.
इसी साल भारत ने इंडिया एआई मिशन शुरू किया है.
I was very shocked to see that so many of these solutions were actually being built by Indian engineers. Now my question to you is that how does a tech company like Siemens approach these complex solutions? Because this is not an easy problem to solve.
Actually, it's not that hard.
So I'm regularly noticing the word industrial AI. Could you tell everyone what exactly is industrial AI and what are the opportunities?
The number one difference is that
This is Dr. Peter Koerte, Chief Technology and Strategy Officer at Siemens AG. And in today's interview at the Cutting Edge Show, Dr. Peter Koerte will share his valuable insights on the future of industrial AI and the next big opportunities for Indian businesses. Make sure you take notes from this episode because top students will get a certificate of achievement. Details are in description. There's a lot to learn from Dr. Peter. So without further ado, let's get started. Hi Peter, welcome to India.
Thank you. Thank you for having me.
So before getting into the questions, I would like to tell everyone that Peter and I are in Mumbai for a very special event called Siemens Transform Innovation Day 2024. Would you like to tell everyone what exactly is this event about?
Yeah, this event is about how we can help the Indian economy to achieve its goals with regards to the growth of 7.5% on GDP and how to build a manufacturing base, increase the share from 15% to 25%. And as you know, at Siemens, we provide all the technology to make sustainable infrastructure, to build state-of-the-art digital native factories. So very, very excited about discussing with Indian customers of what it takes to get to that next level.
I mean, I feel very lucky that you've invited me for this because just before this session, I had an opportunity to see everything that you've been building so far. But India as a country has so many varied businesses, new age startups, MSMEs, and every company, every business has its own unique challenge. So as a tech company, how is Siemens approaching these unique challenges?
Yes, we first off, we focus on two different things. Number one is on larger companies where we obviously work very much hand in hand and in a direct sales motion. But then also with regards to the SMEs that you mentioned, India has 60 million small to medium-sized enterprises. We need to find a good way of how to interact with them. That's why we launched 2 years ago at the Inno Day in India, the Siemens Xcelerator, which is a curated portfolio that connects very easily between the hardware and software, that brings in an ecosystem of many different partners on a marketplace that everybody can go to and find the elements that they like to see. Now, you're right that every business in India has somewhat a different need. They produce different things, they have a different setup, they have different tools, methods, knowledge, and all of that sort. However, what we find is there are use cases that are there over and over and over again. Let me give you three. One is the machines. It's about predictive maintenance and making sure that the machines are having their uptime. And irrespective if you are a producer of contact lenses or if you produce some food and beverage, it's always the same problem that we try to solve. So we provide the basic tools to them in order to solve uptime. The second one is about energy and energy efficiency. It's about sustainability and reducing your CO2 footprint. So we see that use case over and over again. And the last one is right now is how can we lower the hurdle in terms of technology adoption, which is really low-code environments where people very flexibly can put things together because sometimes the skill level is not there. Where we have a low-code platform which we can provide to anyone and they can switch it on and then start coding and develop their applications.
So how does somebody go to this accelerator? Like, how should we imagine this? Is it like a marketplace or an ecosystem of tools?
Yes, it is both actually. It is an ecosystem. However, that's on the supply side. So the demand side comes really on the marketplace. Yes. So you go there. Usually, you are let's say a manufacturer of a certain industry from a certain industry. Let's say again the example of food and beverage. So you may, of course, do in your search engine, you say, I have an issue with regards to energy efficiency in dairy and whatever dairy production processes is required. And then you Google it, or you search it, whatever search engine you use, you end up on the marketplace at Siemens. You find it already tailored to your needs for food and beverage, where you find the 7 to 8 major common use cases and challenges, where then Siemens and its partners provides easy to use application in order to make that work.
So I'm regularly noticing the word industrial AI, even in your keynote. Even right now, the example that you gave, that's not a single consumer, it's a proper industry. And most of our viewers know about consumer AI, but you are tackling problems for industrial AI.
Yeah.
Could you tell everyone what exactly is industrial AI and what are the opportunities, specifically in the Indian context, that we can look forward to?
Yeah, sure. So first off, what's the difference between AI, or consumer AI, as you picked it, and industrial AI? The number one difference is that if your AI, in assisting writing you an email, gets the tone wrong, there's a little bit of harm done, but you can figure it out and correct it easily. If the AI gets it wrong, when for example, you produce, any kind of dairy or any kind of cars or whatever that is, the harm can be outright, detrimental. So therefore, the level of precision that is required in the industrial world is much higher. So for us, industrial AI has 3 components. It needs to be safe, it needs to be reliable, and it needs to be trustworthy. And that's what industrial customers usually ask you to do. And that's what we provide to them. So in our case, in industrial AI, to give you an example, is where usually there's a lot of repetitive tasks, right, that you can teach the machine in order to do it on behalf of us humans. There's one particular operation that is called pick and place. So if you, for example, in packaging, you have to take many different elements and you assemble them and you put them into a box, you wrap the box, and then you ship the box. And you do this the whole day. I tell you, if you do that, it's very hard on your mental health in that regard. A machine can do this much better. And so this is where we brought what we call a pick AI, which actually is pre-trained, and it can pretty much already now, the cobot can take this, and then already sort it and to put the bin picking and put it down there. And that is fantastic because that frees up yet again our creativity as a human to solve other problems.
So India has a very visionary goal of becoming a Viksit Bharat, right? And to become Viksit Bharat, we need to be fully developed and tech-enabled by 2047. Now, as the Chief Technology and Strategy Officer at Siemens AG, from your own personal experiences and observations, what do you think about India in general? Are we on the right track? And if not, how do we make sure that we reach our goals?
Yeah. So India has tremendous potential, as you know, a population of 1.4 billion people that has a demographic that's clearly in your favor because you have so many young, energetic people that is clearly educated with regards to being able to communicate into the world in plain language, meaning English in that regard is an outstanding advantage that you have as a society, and which is very, very exciting to see. And on top of that, you can build almost anything because after all, it's humans that build things. So as on your path to 2047, what we already see right now happening is that the first stage is of course building out all the infrastructure that is required. So really thinking about the railways, thinking about the transportation, thinking about the energy sector with regards to renewable energy, thinking about all the buildings that you see that are more energy efficient and such. So building an intelligent infrastructure from the get-go is a unique opportunity in India. Then it's, of course, as you build that infrastructure, usually it happens in parallel, you're going to attract a lot of industry because the industry comes and says, there's a lot of ports, airports, logistics is very simple to get things around, to get it into the country, out of the country. That's then happening as we speak. As you know, there's a lot of electronics that is being invested into, semiconductor coming in, batteries is coming in. So as that is coming, then you build again your ecosystem around certain industries. And on top of that, then you build your final products around cars, planes, whatever, alongside with a lot of digital capabilities and software, and industrial software, consumer software. So all of that is happening in India. And you have, as I said, everything in your own hands because you got the population that is eager and willing to learn and to contribute.
And I was very shocked to see that so many of these solutions were actually being built by Indian engineers in your Bangalore office. And the solutions that they're making are revolutionizing almost three very big industries. So first we have all of the big manufacturing industries, then we had mobility, and then we had infrastructure. Now, when we address these three different areas, there are three key factors that come into play. We have sustainability, we have efficiency, and then productivity. Now, my question to you is that how does a tech company like Siemens approach these complex solutions and make sure that all of these three factors are taken care of? Because it's not an easy problem to solve.
Actually, it's not that hard because it's always a question of how innovation is being created. Is it technology forward, what I call, or it's a customer backward approach? So what do I mean by it? Very often we have, let's say, the hammer, right? And then the hammer looks for the nail that actually can solve. And that's one approach that you can take. What we find, though, is although that potentially scales, very often it's not missing, or it's missing the right use case. So the much better approach is to work the other way around, to come backwards from the customer. And usually that starts with specific verticals in mind. Yeah? So food and beverage industry, I can tell you, right now has major sustainability challenges with regards to biodiversity and variability in the input materials, so that we as a consumer, it always tastes the same and they have to take care of it. Whereas in a battery manufacturing, that's a very different proposition, because for them it's all about scale up and how to get your gigafactories up and running and getting the OEE and the plant effectiveness overall really going. Yeah? So it's a very different problem. Therefore, what we have at Siemens is we have vertical specific experts that sit with our customers together, that understands the very problems and the key challenges and the use cases they're in, and that are then able to translate, and that's where the magic happens. They're able to translate that problem into, we have this kind of technology, this is how it could fit. As an example, what if we could build digital twins for food and beverage so that we actually can simulate if the input factors change, thereby then I can adjust my process parameters so it always tastes the same. But I also can use the same technology in semiconductor or in batteries and say, what if I build you the digital twin of that factory so you can simulate it first, but then later on, two very different use cases, similar technology. And that's how we approach it. So we always start with the customer use case in mind, understanding what scales, what doesn't scale, and then look like into our accelerator toolbox, if you like. Yeah. So looking at all the hardware that's intelligent and all the software that's intelligent, bring it together, and then jointly and very often work together with partners, implement it with our customers.
But I'm very glad that you mentioned digital twins, because I would like to tell everyone that I will put videos of the exact demos as well. If there's a very massive industry that has to put in a bunch of money to test their operations, instead of spending your money in a physical capacity, you can have your own digital twin, which was absolutely mind-blowing. First of all, how did you even come up with this? And what are the most amazing use cases that you have seen companies try out in this digital twin sector?
Yeah,
because this was my personal favorite.
The digital twins are fascinating indeed. And it has been a journey. I would say the journey started somewhere in the 1970s and 80s. It was pretty much in aerospace and automotive. And it was always about how can you create a sophisticated industrial product. Yeah, that's but in the digital space, so that you can test it there. It was crash testing. That was really the key driver behind also the emergence of CAD, computer-aided design. What happened is we developed these CAD models, so the design models, but then realized as well, just having like the shape of this glass will not cut it. But what if I can simulate? I can simulate the heat dissipation. I can simulate of how actually the computational fluid dynamics is going to behave when I shake the water in here. I can do whatever kind of acoustic testing and so on. So that actually this thing, which is in the real world, I can take it one by one into the digital world, and it not only looks the same, but it behaves the same, because I can run these multi-physics, that's how we call it, multi-physics simulation. And so if you like, over time, these models have become more and more sophisticated. It's all pretty much based on math in order to make them, behave like in the real world. So some of the very super exciting ones are obviously, if you go into, for example, pharma and pharmaceutical testing, where we now not only are able to do, of course, inorganic parts, but organic compounds, and really can see how molecules behave when you are mixing and shaking them up. That's fascinating to see. But also in the non-organic world, such as, for example, with HD Hyundai, if you see some of these very, very big ships, right, being developed in the digital space, which have 1 million parts, and you look at them of how they behave with regards to being CO2 neutral because of ammoniac propulsion, it's fascinating. Yeah. It really is. And so it's a little bit like a kid in a candy store. You can say, wow, do me all the cut throughs so you can look into the ship, you can do all the cross sections and so on. So it's fascinating. And it has really helped and changed many of the industries that we serve.
The demo that I saw had this very massive machine that was sort of spoiled, and they gave me that VR headset, and then I was able to enter the digital twin of that factory, and I was able to fix things and test if the solution would work or not. Which means that moving forward, if somebody adopts your digital twin, they can save so much of time and money.
Yes.
And it can eventually end up with new medicines being formed, new innovations being formed. But now my last question to you is that as a leader, when you have so many exciting things to work on, every industry you touch, there are like 1,000 problems to solve. How do you prioritize which problem to solve first?
So, thank God there's no central way of only one person saying this is actually what needs to develop, but we have a lot of intelligence across our company. Of course, what we do is we look at growth verticals that have particular needs, such as, for example, data centers is one of those verticals that we see is a huge potential, as you know. In particular in India, we got all the co-locators and also the global hyperscalers building up massive amount of data centers. As you do so, you have to do a lot of simulations, still have to do a lot of electrification and also linkages to the power grid. And this is where clearly we prioritize, right? Because we can say this is an industry that's here to stay. It's also propelled by the AI acceleration. So obviously there's a bigger need for data centers. So we invest more in that regard. And so I can pick you a lot of other verticals as well. However, what we also then do is, as I said earlier, we translate that into technology development. And some of them are just scaling horizontally regardless of the industry that they serve, like in digital twin. And that's where we then realize that's a good area to invest in. And that's what we've done 2 weeks ago when we announced that we will be acquiring Altair, which is a leader in simulation software, in particular for nonlinear and for electromagnetic simulation, which were elements we are not as strong today in our portfolio, which is a perfect match because now we can build the most AI-powered comprehensive digital twin in the world, helping our customers even better to become even faster and even more precise. For us, it's absolutely fascinating, and that's how we prioritize.
But how do you see human beings interacting with so much of new tech, right? Because metaverse as a concept is so new. Digital twin as a concept is so new. So how do we make sure that these Indian businesses adopt these tech stacks?
Step by step. Not every customer, as you said, has very different needs. Some of them are further advanced, and for them, they're used to CAD drawings and simulation. For them, the leap to taking digital twins and then thinking of a metaverse is a very different conversation and a very natural conversation than if you have somebody who is about to start up their business and they want to connect the machine in order to improve uptime and efficiency. So you have to have a really measured response. But the great thing is, with the accelerator portfolio that we provide, it's like a Lego toolbox. You pick the pieces that you need in order to make this very problems, go away. And so you don't have to take the most sophisticated pieces, but you take the ones that are simple and easy to start, always driven by the return. Because if we only solve the customer problem in a very fast amount of time, then they will invest. And that's what Xcelerator is all about, having a scalable platform in order to help them on achieving their business goals.
If there's a business owner watching this video right now, how do they access this accelerator? Is it publicly available? Is there a website that they can go to?
Yeah, it is. First and foremost, you would most likely encounter it through two different ways. One of which is either us or our partners will approach you and have a conversation about, your problems. And at some point, they may mention the accelerator and say, we have this portfolio that can help you solve this problem. Or the other way around, you usually don't look for Siemens Xcelerator, do you? You would look and say, for example, going back to the food and beverage industry, and you would say, well, I have a problem with spray drying in dairy in food and beverage. So you Google it, hopefully, or you have your search engine, and hopefully it will lead you to the Xcelerator Marketplace. You get on this Xcelerator Marketplace, and there you find a dedicated section, which is only for food and beverage, where you're going to find use cases, references, and then also about the top 5 to 10 challenges that you usually face as a dairy manufacturer. And it provides you with proven solutions that you can look at. Then it next takes you to a try and, a try step where you can say, let me try that solution if it's digital. If it's digital and hardware, we are happy to ship it, and then you start to deploy it, and off you run.
Very, very cool. I will make sure that I share all the links in description. In fact, if you go to our Instagram page, you will see a highlight of everything cool that we saw. We've made sure that we cover everything exciting. But Peter, thank you so much for taking out the time. Thank you so much for pulling across such a crazy event. I know that it's a teamwork, but you being at the helm, I know how difficult it is to manage so many moving parts, and hope you keep visiting back to our country again and again, and hope to see Siemens Xcelerator fixing all the amazing problems towards the Viksit Bharat.
Well, thank you very much for having me today.
Thank you so much. If you enjoyed learning from this episode, make sure you click on subscribe and hit the bell icon right now. We regularly upload valuable interviews, crash courses, and career advice in the field of tech, design, and marketing. We've launched free learning platforms like howtoProm.in and learnuiux.in that will help you upskill yourself for free. We've been training corporates and enterprises all across the world on using the latest AI tools to boost overall efficiency and quality of work. If you want us to train your team, then send us an email on collab@anshmera.com. If you want to learn the basics of AI and prompt engineering, then this crash course right here will help you get started.